Our final speaker is no stranger to SATURN, having served as a technical chair before and a member of the technical committee. George Fairbanks currently is a software engineer at Google. He brings a lot of experience in teaching and coaching software architecture and design that's dating back to '98, including a co-teaching gig with David Garland back in 2007. He is the author of the book Just Enough Software Architecture. George holds a PhD in software engineering from CMU, having been advised by David Garland. So without further ado, please welcome George.
Thank you. Okay, is this working? Success. Okay, great. Probably right about now, you guys are wishing you hadn't had the dessert at lunch because your sugar crash is starting to go. So I'll try to be a little bit animated to keep things up. I have a quick question for you. In the work that you guys do, how many of you have either formally had to teach other people architecture or informally try to mentor other people to teach them about architecture? Well, that's probably why you're in this session. Okay, so good. So I've had some trouble with that. As was mentioned, I, in the late 90s, was employed as a road warrior. So 50% of the time I was running around on airplanes, well, via an airplane, to somebody's company, teaching them object-oriented analysis and design. And teaching something over and over and over again, you get better and better at it. But you become frustrated, well, at least I became frustrated, because I'd try to prefetch whatever problem occurred last time. And I'd say, well, what can I do to the course? How can I rearrange it so that I don't have that problem again? In other words, I wanted to make the knowledge transfer linear and effective. And as it turns out, we got pretty good at that as a group, okay? Not only our company, but everybody was teaching OO analysis and design pretty darn well. There were a lot of advantages we had going for us. The first is that there were a lot of different courses, there were a lot of different teachers, and there was broad industry pull that they wanted this information inside them. And also, what we were talking about was programming in the small. I mean, you could fit an example on a page. But architecture continues to thwart me, and I don't know if it does you too. It's difficult to teach this to other people, not only because there are fewer courses on this, there are fewer teachers on this, but it's programming in the large, right? Nothing fits on one page. It's not like design an algorithm to do something or use this cool feature of Java. It's like the examples you've just seen in the previous two sessions. You have these giant things and you're trying to grapple with them and get people to understand. So basically that's the motivation for this talk. It's how can we become better at teaching these hard topics that we find important? So there's probably two different kinds of people in the audience right now, or at least maybe you have two different hats to some extent. The first is, in that role that I had you raise your hand for, I hope that I can make you guys a little bit better, teach you a few tricks that I've come up with. But also that there are some concrete lessons in here that if you're still somewhat new to architecture, you can learn from those things. It's also a little bit of a peek behind the curtain in the sense that as I say, look, I'm having a really hard time teaching this. If you're having a hard time learning it, there's a reason for that. Here's the basic structure of the talk here. And realize that I can't actually teach the entire course that I'm talking about. So again, I have to sort of compact this thing. But this is the basic outline of it. The first thing what we're going to do is we're going to talk about the obstacles to teaching as far as I recognize them and the pedagogical strategies that I'm using to try to overcome them. I'm going to talk about those in pairs. So they won't be all the obstacles and then all the techniques, but they'll be matched up. Then I'm going to talk about the actual course itself. The list here are the actual learning points that I have, slides on in the course, and you'll get a good idea about what the course is. Okay, so the course is over here, and the left part is the ideas that underlie the course. Understatement of the year. Okay, teaching architecture is hard. So we're going to see a bunch of these paired up slides now. The first obstacle is that there's low motivation for people to learn architecture. This may seem surprising. what was it we learned in the keynote this morning about the software architecture is one of the most desirable positions, and yet when you're probably in your companies, you're running across a lot of people that just want to learn how to program Java better, or they just want to learn REST, or maybe REST is even architectural. Okay, so but they want to jump in on some very detailed topics, and they don't want to learn the theory that's in the software architecture and practice book. They don't want to learn how to make a software diagram. So there's not a lot of motivation. You may have heard the expression, their cup is already full. There's a lot of hubris. There's a lot of arrogance in our field. I'm sure you guys don't have any, but I have a little bit on time to time. And sometimes my cup is already full. I'm running across a lot of other people when I try to teach them something, they're not ready to learn anything, okay? So they're also being very tempted by other short-term payoffs, right? They could go read a blog post. They could read Joel on software and learn deep insights about software. Or there's also this other problem is I think that actually talking about generations is difficult because you read the Greeks and the ancient Greeks, and you still find they say things like kids these days, but I'll say it anyway. Kids these days seem to be, want the blurb version of something rather than the think about this for a long time. So here's what I'm doing to try to overcome that. I read this, and I can't find the reference now. There's a journalism class, imagine, and the teacher is trying to teach these new students on the first day about how to write a good headline. And the teacher could say something about what you want to do is look for the story behind the story and da-da-da, and the students would go, yes, yes, all that sounds very good. But instead, here's what the teacher does. Gives them a situation that says, on Thursday, the teachers are going to be in an off-site meeting. It says, please write a headline. Gives them about a minute. They all come up with their headlines. What do the headlines say? Something like, school teachers in off-site Thursday or something, right? And he goes, no. The headline is, school's canceled on Thursday. So the point of the story is, if you can quickly establish to people that they're like, oops, I'm going to do that wrong, then they're much more motivated when you start teaching them how they can do it right, okay? So I use this strategy in the course. We're going to see the outline of it in a minute, but we start out instantly with an exercise in which they draw a diagram, and then I make fun of it. Actually, it's a much nicer version of that. You'll see in a minute. But basically, we show them that their diagrams are imperfect. And then the second thing that goes on that I want to show them about failure is even though I suggest that they focus on how to make a clear diagram, because we're just coming up with an example, right? I'm not actually asking them to build a system. And I say focus on making this diagram as clear as possible. They're engineers, right? We're all engineers, right? And what happens is, the blinders go on, and we're going to try to do the best job of building this system we possibly can, as if it's relevant, right? If in 90 minutes, nobody's going to care. But that's what they focus on, right? So that's a second kind of failure that you can point out, that in real life, you're going to do the same thing. You're going to start worrying about the implementation. You're going to stop worrying about communication or thinking about it. Second obstacle. Software architecture ideas are abstract, right? By definition, they're abstract. The second problem is that some people seek abstractions, probably more prevalent in this community here, right? We're much more likely to seek out abstractions because we know that sometimes we're looking for the generalities and our coworkers are looking for the concrete problems, okay? Or the concrete solutions. So the strategy I have here is to make some of those abstract things tangible. And I do that in two ways. First is that I scope the course to be focusing on a concrete activity. So instead of talking about how to analyze things or how to think about things, I say, you want to make diagrams that go in your design docs, right? Yes. Okay, good. Because sooner or later, you're going to have to do that. And then I teach them how to make that diagram better. And second is that the course sequence is very heavy on exercises. There's an exercise, and then there's some abstract theory stuff, and then there's another exercise. So focus on the concrete stuff. Make sure you got the bases covered as far as abstract people and concrete people. And you take these fuzzy, or not fuzzy, but abstract architecture ideas and make them very real. Next obstacle. There tends to be a big investment before you get a big payoff with software architecture. How many people in here feel like they really mastered the information that's in any one of the SEI books? Okay. That does not count, Len Bass. You cannot do. All right. Okay. Okay. Well, that's fair enough. Okay. I'm going to hide behind this now. But that's the problem, is that no one here feels like they've actually really mastered and internalized all that stuff. It's a real big impediment, and yet we still have to make some forward progress. And this takes years. So my strategy for this is to teach a small common task. At least in this case, it's diagramming. The topic itself is tiny compared to all of architecture, and I'm not even going to try and teach them how to make all diagrams perfectly, but just make some diagrams better. Another idea I have thought about, but I haven't tried, is I got this one from Mary Shaw, actually. If you take a look at the comp risks, it's an old Usenet mailing list which has a modern equivalent. Basically, they teach failure stories like the Ariane rocket blowing up and say, here's how this stuff happened. That stuff is very visceral to people, and I think that would be a great way of connecting people because no one likes to have catastrophic failure on their watch. Next obstacle here is that, in my experience, developers make predictable errors when they draw diagrams. They mix abstraction levels, they omit critical details, and I'm going to show you some examples of what that might look like if they were drawing a dog. The first is, this is a dog that's missing legs, which might be like, here, I'm going to describe the system, but I'm not going to tell you how the allocation works, or I won't tell you about module dependencies. Just arbitrarily removing details. Or here's another one that focuses in detail on one thing, like I'm going to tell you everything about the modules, but nothing about the runtime. Or it might be a fairly complete picture of the dog, but for no reason in particular, there's great detail in one particular area. Okay? You guys may have seen this kind of thing before. Okay? So the reason for this talk is the solution for this, is that my strategy is to teach the meta model first, i.e. focus on the legend. So I give them just enough theory about the ideas that are in architects' heads, just enough theory to succeed at a concrete task. It's sort of a tantalizing glimpse at this cognitive model that's inside Len Bass's head. So I've just shown two examples of legends that I use in the course. And the message that I'm trying to convey is the details that you choose to put in the legend, assuming the diagram follows, the details you put in the legend, they tell you what you could possibly learn from such a diagram, right? And just by looking at these two legends, you can ask people like, well, what could I learn from the diagram that came with that? Or what could I learn from this diagram? And you realize there's very different things. On the left-hand side, there's clearly a time dimension to it, right? You could see some sequencing of when the artifacts arrive. And over here, maybe it's more clear what the dependencies are between things. And so therefore, you could answer different questions with different diagrams. So it gets them to focus on something relatively concrete and hopefully points them in the right direction. Another one that I mentioned before is this programming in the small versus programming in large problem. And so the question is, how do you deal with architecture-size problems in a very short amount of time? I have a really bad answer for that, which is spend a lot of time on exercises. It's the only thing I've come up with. More than half the time in the course is spent on exercises, but it seems like the least bad thing. Let me know if you have a better idea. There's also a general pedagogy thing that I follow, which is the I do, we do, you do pattern. So I show them how something works. We sort of work on an example together, and then they go off and do the exercise. So here's a summary of the obstacles and strategies. I believe this is the core thing that I want you guys to take away from this session here, because I think that this is going to rhyme with several other problems that you're seeing, whether it's giving a presentation to other people or developing your own training or just communicating with somebody else. Some of these things will look similar. You'll have a similar sort of pattern of, I saw that problem, I can try this technique. What? The slides are all going to be online, so you probably don't need to take pictures of the screens. But if you like. Okay. So here's the outline of the course, so you get an idea tangibly how the 90 minutes in the course are allocated. The first thing is part one. The students come in and do an exercise. I'll show you that exercise on the next slide. We say hello, we set up the agenda, we say here's the goals of the class, but that's like a couple minutes. They work in groups of 2 to 3 for most of the time, probably about 15, 20 minutes. And then when everybody's drawn their diagrams, I have everybody rotate, as you might imagine, and say, explain to me what your coworker did to solve this thing. And what I do is I also prefetch some of the lecture topics as I go along. So I say, hey, did you notice this? Because I know I've got a slide on that in a couple minutes. The second part is the traditional lecture kind of stuff, the boring abstract stuff. And my goal here is to get them to think like a coach instead of a rookie. I love this metaphor. Imagine you're sitting on the sidelines of an American football game. I'm going to use American football because it's more complicated, right? And let's imagine you're sitting next to a professional NFL coach, and we're both watching the same game. We're both seeing the same things happening, right? But what you understand and what he understands are vastly different. And it's not because his eyes are more acute than yours. It's because the things that are going on in his head, he's prepared to see different things than you are. So all I'm trying to do in this course, between the do the first exercise and do the second exercise, is to get a little bit of knowledge in their head so they see the same stuff differently, like that example with the legends just a minute ago. And then finally, what they do is they go ahead and they do the exercise again, hopefully with dramatically improved results. So here's the actual exercise I have them do. Anything suitable would work out, but I happen to use this library exercise in classes. Basically say, there's a library. You can check in and out books, beep, beep, beep with the scanner, okay? But imagine there's lots of computers in the network, and what we want to be able to do is not have the whole thing shut down if the network is off. Okay, so the guys at the desk can still check in and out books, even though that happens, and they have to do it fairly quickly. And the reason I put challenges in here is it focuses their diagrams on some particular challenge as opposed to, who knows where they're going to go. Okay, I specifically call out, and it's bolded just like this, that I'd like them to give me one or more diagrams readable by other engineers that are focused on those particular challenges. Okay, so there's not a whole lot of text on here, and I am saying specifically I'd like these things, and then we get about 15 minutes. I come back about 5 minutes before the end and say, at this point you probably want to throw away everything you've got and redraw your diagrams because the focus is on making these things readable by other people. Okay, so I'm telling you, I'm really trying to get them to focus on what they want, what I'm trying to teach them about. Okay, but invariably they draw a general diagram instead of drawing a diagram that's helpful at explaining their design regarding network outages. They almost never draw more than one diagram. And even though I say this 5 minutes before the end, they rarely make anything that's designed for somebody else to consume. Okay? Because again, they're focused in on this cool engineering problem of how did they tolerate network outages, because that's fun, and diagrams are not fun. This is mostly a slide for being online, and you guys can use this eye chart later. But if you want to think about doing course design, there's some great things you'd like to be able to tell them, but notice I've only got 30 minutes of lecture to do, okay? So what I had to do was I had to sort of prioritize how badly do I want to teach this thing versus what are all the dependencies of other things I had to teach them before they're ready to consume this, okay? So those are the two dimensions here. So by conceptual model sophistication is more and more dependencies that they need to already understand, quality attributes, et cetera. And importance is, how much do I really care about this, okay, in terms of diagrams. So what I did was I sort of mapped these things out, and I made it into 3 different courses, the simple, the advanced, and a full general architecture modeling course. Okay, so you're probably going to need to do something like that too. Here are the actual lecture topics, and so it's not a huge number. The annotations right after that say JESA are the sections of my book, Just Enough Software Architecture, so you can find the exact section. The whole idea here is that I'm not publishing all the slides here, but you probably could reproduce the course with this outline. The first thing they're learning is what diagram should you build. The concept here is question first and model second. If I said, build me a model of the train network, say the subways in New York City, you might build me a lovely model that could predict when a given train is going to arrive at a station. But if I said afterwards, but actually I wanted an accounting model of that train network so I know when the train's going to wear out and I have to buy another one, right? That's a problem. Because they're both models of the train network. I just didn't tell you which model I wanted, and every model throws away details. okay? So you've really got to figure out what is the question I want to answer with this model. Otherwise, you stand no chance of getting the right one. Oh, unless you make one that's sufficiently bland that it doesn't answer any question particularly well, but it answers a lot of questions a little bit, okay? So that's the question first and model second. And as you might imagine, that's very much connected to what you put in your legend. If you put the right things in your legend, you might be able to answer those questions. But if I read your legend and it had trains and times and platforms, I could know right away that you've built the wrong model for answering the question about accounting, right? So the second thing is they don't know what kind of diagrams exist. So what I did was I dipped deep into the trove of SEI materials, and I teach them that they probably should know about the 3 view types, that there's diagrams about your static stuff, your module view, that there's diagrams about what happens at runtime, the component connector view, and then there's diagrams about your hardware or other kinds of allocations, okay? And you probably want to choose one or more of those things, but keep those details separated from each other, okay? I give them prototypical diagrams and say, any given diagram should probably only be one of those types, because as soon as you overlap them, you run into trouble. And then finally, I talk about the kind of details you include in these things. I say, please use a legend. Here's how you think about it. You want to eliminate all the details that are not related to the question that you're asking. Avoid the non-semantic cruft that you often see, like 3-dimensional extruded, monster, colorful, CIO diagrams kind of stuff. Avoid naming on technology, so don't say store it in MySQL. Say store it in the inventory database, right? Because there may be multiple MySQL ones. And the one about arrowheads on diagrams having multiple interpretations, so watch out for that. And of course, that's just bait. They love to argue about that one, okay? So reflection. So how do I think the course went, and how do other people think the course goes? Overall, I say it's pretty effective in a short period of time at sort of hooking people and making them a little bit better at building software architecture, software diagrams. Okay, so that works pretty well. Feedback has been positive, even the indirect feedback that I hear from other people when they end up talking about the course. So they're not just trying to make me feel good, and it looks like they may come back for more. There's always a problem with mission creep. Remember I talked about with the OO course that I used to teach that I'd always try to rearrange it and avoid the problems for the next thing. My problem that I'm having is that I know I can fix that problem. I keep trying to put more and more things inside the course. Okay, so there's a little bit of mission creep on that. Another thing, though, that's negative is that the students backslide super fast. So the things that they're able to do, it's a dramatic improvement from they do a bad job of diagramming, lecture. They do a pretty good job of diagramming, but boy, you come back 2 weeks later and there's a lot of things back in their diagrams, okay? So for example, one of the things I talk to them about is if there's anything in your diagram, make sure it's semantic, okay? It means something. So like if 2 things being abutted next to each other is supposed to mean something than them being separated, then that should mean something. And then 2 weeks later, I'm looking at their diagrams and they've done that again, right? They've fallen back into that bad pattern. The one thing is, though, that everyone uses a legend afterwards, okay? But what they don't always do is they don't always manage to get everything that they care about, all the semantics, into the legend, okay? So we're going the right direction. But let me tell you a little story about that. Please use a legend. This was unfortunate. I felt really bad when I heard this feedback. I heard a couple other people talking about my course. And somebody said, well, what was the summary of the, what did you think of it? And the person said, put legends on your diagrams. Okay. And it was really upsetting. And what was even more upsetting is I couldn't decide why I was upset, because that is what I want them to do. I want them to think about putting legends on their diagrams, but it was still unsatisfactory. Okay. So here's the reason I've come up with for why I'm unsatisfied. Imagine that someone chooses to take time out of their day and tells you about the golden rule. Be nice to other people because, or, act to them like you'd have them act to you. Okay, and they talk to you about why that's the case. The upshot, the answer to that whole thing is you should be nice to other people because you want them to be nice to you. Right? That's sort of the conclusion. And so saying put a legend on the diagram is like jumping to the chase and saying cutting to the conclusion. But what I'm trying to do is I'm trying to instill the cognitive model that lets them derive that conclusion at any time that they want to. They not only put a legend on the diagram because I told them that it's the right answer, but now they understand what role the legend has in assigning the scope, figuring out what kind of questions this diagram can answer. So that's the reason I was upset by that answer, because I could have told them that in one sentence, right? Put legends on diagrams. But what I was trying to do was, change their way of thinking going forward. So of course, what I did was I add this story as the last section of the course, and that seems to work pretty well, and I get a laugh out of it too. Okay. So that's it. That's the summary of the talk. I'm hopeful that what I've talked about here today, it's interesting to you in its own right, but also that you can use some of these basic patterns of how to overcome obstacles in places where you are going to do some teaching on software architecture as well. And yeah, I think that's it. All right. Thanks very much.
Thank you, George. Any questions?
So I can see this would be useful for teaching those who would practice architecture. Have you used it or tried to use it on people who are more sort of the side stakeholders of architecture, maybe in the business side, the ones that you rely on to create the architecture, or others like that?
I have not used it on any stakeholders other than software engineers. That's the only people I've tried it on. Yeah, I think that you'd probably end up with different obstacles on that. The lesson might still be the same. It's always hard these days to get 90 minutes of anybody's time for some topic like this. And they'd probably insist that I just teach them on the spot, which is probably what I would end up doing. I'm not saying that's the right thing. I'm just pragmatically saying that seems to be what would happen.
Thanks, George. Very interesting. Do you at all include design patterns or anti-patterns as part of this training approach?
I haven't yet. One of the things you'll notice is that there's only 30 minutes for lecture, and I'm trying to cover a topic that's, really woolly. I mean, like, I can already lead you guys to the idea that the legend influences what's going to happen in this diagram, but you were already primed, right? You were ready to receive that, or you already knew it. But no, I don't have time to get the patterns and anti-patterns in there.
Yeah, the one item, George, that I'd like a little more detail on in these examples, when you mentioned the programming in the small versus programming in the large. Now, in my experiences, there's qualitative differences as well as quantitative differences. Yes. Now, you mentioned that the strategy is basically lots of exercise time. Okay, now, but that doesn't quite get it. How do you communicate the qualitative differences between the two?
I'm really upset that you asked that question because that actually was the least satisfactory answer in terms of those pairs of like, here's the obstacle, here's what you do about it. And that's why I said, if you've got a better idea, please bring it in. Because you're exactly right. The qualitative differences are, number one, that most of the people coming into the course they're not already primed to believe that software architecture concerns are anything other than lots and lots of code, right? And in fact, I think you guys are all on board with this, right? But the difference between how do I build a car and how do I build a transportation network are two completely different problems, right? Your ability to craft an algorithm and your ability to steer an enterprise are completely different things. I hardly need to tell you that. That's your job. But yeah, so I don't have a good answer on how to do that in a short period of time. I don't know how to carve off a little concrete task. This is like my ability to get a bunch of skeptical developers, right, who are not highly motivated to pull this knowledge. Instead, this is a way to get them hooked in, and so that maybe then they'll start following the thread and end up here at SATURN next year.
One last question. It's going to be the winner.
You may have just answered this question, but I was wondering where the 90-minute constraint came from. And because if I wanted to teach someone pastry, being a pastry chef, or to learn a violin, 90 minutes, you know? What gave you the idea that might even be adequate?
That's a good question. I'm not trying to say it is adequate. I'm saying it's adequate to make some improvement. I was shooting for 60 minutes, and it just became impossible. In fact, some people gave me feedback that it should be 60 minutes because an hour should be plenty of time to figure out stuff. See earlier comment about Twitter generation. I mean, like, yeah. So there's another quote on the slides that I don't think I talked about, which was, and again, I don't know where I got this one either, but I love it. You can't learn calculus by hanging out with guys who know calculus, right? There actually comes a period of time where you need to like hit the books and sit down and study this stuff. But it's almost like as soon as you escape undergrad these days, with the people that I'm hanging out with, that they don't seem like they need to sit down and hit the books. It's like all blog posts and Twitter and sort of short digested versions of things, right? What I guess the best way to think about why did I choose 90 minutes? Well, it was the shortest increment that I could get something done outside of 60 minutes, and I feel like I can get enough motivation for people to say, hey, you have this design document. Wouldn't you like to learn how to do that thing better? And it'll be only 90 minutes. We'll do it at the end of the day. It'll be fine. 4 to 5:30, no problem. Just come on by. Yeah, and that's sort of what I've been doing and cajoling people. I also did. There's also times when you can work with a person who's a broader stakeholder, like say overseeing more than one person, and they say, well, it would be a good idea for my people to take that because I'm not delighted by the quality of the diagrams. That can help out. Yep.
Okay. Well, this concludes our session. I thank our presenters.
Thank you.